Hello everyone, I am Aditya Bhattarai, a Masters of Engineering Mining Engineering student, and I am presenting my paper Comparative Analysis of Ductile Bolts and Rock Bolts Retention of Strength of Rock Mass under Tensile Loading. So let's begin with what rock bolting is. Rock bolting is a technique used to reinforce rock mass in underground excavation by installing steel bolts into the rock and securing them to prevent collapse. There are various kind of bolts that can be installed depending on the need. Example, rock bolts, cable bolts, fiberglass bolts, and D-bolts are few of the common ones. The image shown here shows a mine that is covered in mesh and rock bolts are installed in it to prevent collapse so it can be excavated, evacuated, or for some other needs. Cable bolt is the one that is shown in the right hand side of the slide. Cable bolts are stronger type of rock bolts that uses steel cable instead of rock to reinforce rock mass in underground excavation. It can be pre-tensioned and they usually are more ductile than traditional rock bolts. D-bolts are new kind of bolts which are ductile and have either paddle anchor or wiggle anchor as shown in the figure above to secure the rock mass. This bolt promised to perform significantly better under tensile load. This topic was particularly chosen as failure of mine can be catastrophic. The job in mining and tunneling is still considered dangerous by many, although we've come a long way, and better safety of mine also means more economical mines, and traditional rock bolts are quite often failing due to its brittle property. That's why this topic is important for better performance in tensile loading. The main question that this paper intends to answer is how does ductile bolt like D-bolt and other ductile cable bolt perform under tensile loading? To answer this, a series of tests has been designed to test performance of this bolt in comparison to traditional rock bolt, extending the work of Hyatt et al. 1996 and Lee 2010. These are some previous work which are similar done by various authors around the world, and the research design we prepared for this particular paper are as follows. The first design is laboratory pull-out test. The figure on the right hand side is the apparatus that is used for this test. The sample size we have taken is 60 with 20 cable bolts, 20 D bolts and 20 rock bolts. The bolts are grouted in various kind of rocks to mimic real world scenario. The load applied is 3 mm per minute to the machine to find load displacement curve. The second experiment which we have designed is field pull-out test. The apparatus is in the right hand side again, and the sample size for this one is 40. The 10 of the sample size are cable bolts, the other 10 is D bolt, and we have 20 rock bolt for this particular experiment so that we can compare the cable bolt and D bolt with rock bolts. Installation depth for this is 500 to 1000 meter below ground, and installation in all kind of rock is done so as to mimic real world scenario. It is installed in pre-drill hole grouted with cement resin. Well, the finding of our entire research shows that ductile cable bolt and D-bolt consistently perform better under tensile loading, which is consistent with finding of Lee 2010 and Hyatt 1996. This finding can be used to optimize roof support strategies, improve safety, and enhance the efficiency of underground operation, particularly tackle tensile load. Thank you.